my plan for today is to continue in lesson 6.4 and finish the problems I want to do, which for what we're looking at, it's just problems number 2 and 5 that I plan to finish. Okay, I do not plan to cover 3 and 4. And then you will be able to complete the rest of the homework. So, if you recall yesterday, once we got to the backside here, on number 1, we were given polar coordinates and we took them to rectangular coordinates. And in doing so, I had copied the 4 conversions from the front side of the paper, right? So those were all 4 given pieces of information. So now, in problem number 2, we're being given rectangular coordinates, and our job is to find the polar coordinates. So we're doing the opposite here, right? And if we're given rectangular coordinates, what values are these? Yeah, remember rectangular coordinates are x and y. So we're given x and y, and if we're trying to find polar coordinates, what are we trying to find? Yeah, we're trying to find r and theta. So we're going to start with this problem right here. There is a problem B that we'll talk about at the end, so I'm just going to call this problem A. Okay, we're given x and y. Thoughts on what we want to do to finding r and theta? Okay, so we're going to have to use tan theta equals y over x. That's going to help us find our theta here in a little bit. And we're also going to have to use r squared equals x squared plus y squared. And that's going to help us find the r value. Okay, so technically I don't think it really matters which you do first. So you could do either or. I'm going to go ahead and start with r squared equals x squared plus y squared. If we're looking at r squared equals x squared plus y squared, fill in your x and y values, right? So x is going to be negative square root of 3 over 2 squared plus y is 1/2, so 1/2 squared. Okay, so what is the square root of 3 squared? 3. What is 2 squared? 4. And what's a negative squared? A positive. So this first value is going to be 3/4, if you kept up with that. 1/2 squared. 1 squared over 2 squared is going to make it 1/4. I like the way this math works out. 3/4 plus 1/4. 4/4 or 1. So at this point we have that r squared equals 1. Okay, r squared equals 1. Take the square root of both sides. So what is r? Okay, square root of 1 is 1. Plus or minus 1? You know there's a catch. You know there's something you guys are overlooking when I just sit there and I'm quiet. And I'm kind of looking around, waiting for someone to come up with it. Same old, right? You have to consider plus or minus. And can our r value be positive and negative? Yeah, if you remember yesterday when we looked at some of these, we can go forward on an angle or we can go backward through the pole is what a negative r value does. So, yes, there are 2 r values that we're going to have to consider. Okay, so we'll put that together in a moment. And then our other equation. Tangent of theta is y over x. So, tangent of theta is going to be negative square root of 3 over 2 over 1/2. Yes, it is. I thought I said y over x, didn't I? Yeah, you said y. But then I wrote the wrong one. Okay, so don't follow your teacher's lead is what this is an example of. Sorry, guys. I said y over x, but then, yeah, I just didn't do y over x. So y over x would be 1/2 over negative square root of 3 over 2. I would have figured out here in a moment that it wasn't quite right, but okay, thank you. Y over x. Don't mess up the basics. Now, let's clean that mess up. 1 over 2 divided by negative square root of 3 over 2. Okay, keep change flip, multiply by the reciprocal. What? Not exactly. So if we do 1 over 2, it's currently divided by, so we're going to multiply by. The reciprocal of negative square root of 3 over 2 is 2 over square root of 3, or negative of 2 over square root of 3. So if you have 1 over 2 times 2 over square root of 3, what happens with those 2's? Those 2's cancel, and you really end up with just 1 over negative square root of 3. I don't like how I wrote that. I should have written that as a better fraction as opposed to the slant there. I'm going to fix it just because it's bugging me. So negative of 1 over square root of 3. A good shortcut to notice. Notice we were dividing two fractions, the denominators were the same. The denominators ended up canceling out, right? So we end up with negative 1 over square root of 3. Do me a favor, though. What's another form for negative 1 over square root of 3? Not just square root of 3. Negative square root of 3 over 3. Because if we rationalize this, and you multiply by square root of 3 in the denominator, and you multiply by square root of 3 in the numerator, you end up with square root of 3 over 3. Now, the question becomes, when does tangent equal negative square root of 3 over 3? Now, good news, does this fraction seem familiar to you guys? This fraction should be familiar, right? One of those forms, because if you look in your chart, we have square root of 3 over 3 in the tangent column, yes? According to our chart, when does tangent equal square root of 3 over 3? Pi over 6 or 30 degrees, right? Now, the catch here is that this is a negative square root of 3 over 3, right? So, I'm going to backtrack to the unit circle for a moment. Tangent is square root of 3 over 3 at pi over 6. But what quadrants do we need to talk about since tangent is negative? Yeah, all students, so it's negative here, take calculus. So really it's forget these two quadrants, right? And you're looking at quadrants 2 and 4. Now our angle was pi over 6, right? What is the equivalent angle to pi over 6 over in quadrant 2? 5 pi over 6, right? Because the same distance up from the x-axis. And so this is 5 pi over 6. So one of our two angles is 5 pi over 6. That's what it is in quadrant 2. Okay. What about down in quadrant 4? Okay. 11 pi over 6? Now, I don't remember for sure. In my notes, I used a different name for 11 pi over 6. And I used negative pi over 6. Okay, so if we talk negative pi over 6, is that the same as 11 pi over 6? 11 pi over 6 is going the positive direction, isn't it? But negative pi over 6 is coming the negative direction. Okay, I'd be familiar with both. To be honest, I don't remember right offhand. I need to look it up if there's a specific reason that I use negative pi over 6 in my notes as opposed to 11 pi over 6. I'll be flexible and use both. But like when you look at homework and some of the multiple choice ones, you need to, be aware they're equivalent, right? So we have theta being two possible answers. We said 5 pi over 6, and then I'm going to use negative pi over 6, but keep in mind that is the same as saying 11 pi over 6. Now, depending on the situation, you could also use inverse tangent to figure this out. I didn't use inverse tangent because we were talking radians, and if you're talking radians, inverse tangent is going to give you some weird decimal that doesn't really help. We could use inverse tangent in degrees and get a degree answer here, but keep in mind that's not going to give you both answers because you need two different quadrants depending on whether it's positive or negative. Now, here's the deal, guys. Two R values, two theta values, yes? We're being asked to find the polar coordinates, so we need two ordered pairs. So in order to come up with the two ordered pairs, my suggestion is, okay, let's visualize. Where is the ordered pair, negative square root of 3 over 2, comma 1/2? Where does that end up? Second quadrant. Here's your visual with me. Because if I go negative square root of 3 over 2 left and then 1/2 up, I'm going to end up here, right? So that is my rectangular coordinate there. Now, we've got to make this work somehow. Okay, what are the polar coordinates here? So what angle is this on? Which angle is in this quadrant? This is 5 pi over 6, right? So we're going to use 5 pi over 6. And how far are we going out on 5 pi over 6? 1 or negative 1? 1. Because where would negative 1 take us? Backwards through the pole. Okay, so if we want to go into that quadrant, it's going to be 1. So one of our polar coordinates is 1, comma 5 pi over 6. Because remember, you do r and then theta when you list the polar coordinate. Even though we talk about the angle first. And then, okay, now we've got to use this other angle. The other angle is negative pi over 6, or 11 pi over 6, right? And where is that negative pi over 6 or 11 pi over 6? It was down here, wasn't it? So if I'm using this angle here, that negative pi over 6, how do I get back to this point in this quadrant over here? You're going to have to use the r value of negative 1. Does that make sense? She did. She hit the building. Oh. That was the lawnmower hitting the building. Okay, so this is negative pi over 6. In order to get over to this point here, you have to go backwards to the pole, and so that's negative 1. And so the other polar coordinate is negative 1, comma, negative pi over 6. Which again, negative pi over 6 is the same as 11 pi over 6. Okay? So there's several things to think about and work with there. You have to be careful and take your time. But you should be able to come up with two polar coordinates in the end. It's a matter of figuring out how the pieces go together. Okay? There is a part B here. I know I don't have much room left, but we can go the long way or the short way on this one. And if I go the short way, that means I'm not using the equations. Now, am I saying you can't use the equations? No, you can use the equations just fine. However, we can also do the short way, which is let's look at the graph and think about it and see what you guys can understand here. So this is a rectangular coordinate, correct? Which means we're talking x and y axis. Where is the point -3, 0? X-axis 3 to the left, yes? That's old news. You know how to graph your rectangular coordinates. So I want to know what that is in terms of polar coordinates. So what are my possible R values? -3 and +3. Keep in mind, you're always going to have two R values. They're going to be the same number with opposite signs. So my R possibilities, and we'll put it together here in a moment, are plus or minus 3. What about theta? If you look at the unit circle, what angle is this on? What angle is this over here? This is at 0 on the left side. 180 degrees, which I'm going to call it pi. So one of our angle options is theta. It's theta. Pi. I'm not helping matters any. Okay, so this is pi over here, right? Now, what's the other angle we're going to use? Because if we have a positive R value, we're going out on pi. But remember, what's the value that's on the other side of the pole? And what's this angle over here? That is 0. 0 or 2 pi. But we always use the first one around the x-axis, so we're going to say 0. So those are the R and theta values we're going to use. Now it's putting them together. Okay? So over here when we use pi, if you go out on pi, think carefully here, how far out on pi am I going? Think polar coordinates, not rectangular coordinates. So if we're on pi, we're going out how many rings? 3. And since our angle is pi, we're going out 3. That is a positive 3, because where would -3 take us? Back through the pole. But if our angle is pi and we're at 3 here, then we're going to use 3, pi. I know the tendency is to say -3 because on the x-axis that is a -3, isn't it? But in terms of polar coordinates, that's 3 out, 3 circles out. Now, the other angle we have to use is 0. If we say the angle 0, which is over here, how do we get back over to this point? You have to use -3 to take yourself backwards through the pole. It's going to be -3, 0. Okay, so definitely a little work finding the polar coordinates. I'd say probably the hardest part of what we've had to do, just because you have to really use that trick. Okay. Questions there? I told you we were skipping 3 and 4, and we're going down to number 5. Number 5 talks about the distance formula for polar coordinates. If you remember, you have a distance formula for rectangular coordinates. You've been using it since at least middle school. D equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Remember that big long distance formula? Might have been a while since you've used it, but nothing else. I think I started off with it in the very first chapter of pre-calculus, like back in August maybe. So, okay, so the distance formula for polar coordinates. Here we go. D equals the square root of R1 squared plus R2 squared minus 2 times R1 times R2 times cosine of theta 1 minus theta 2. And of course, this is based on polar coordinates. So that means this is based on coordinates that are r theta. So one of them is r1 theta 1, and the other coordinate is r2 theta 2. Does that formula ring any bells from a chapter 5 formula? Do you see some resemblances? Law of cosines? Okay. So that is actually where this comes from, is law of cosines. Because if you look at, and I know you guys are used to seeing law of cosines in terms of ABCs, right? But if you look at law of cosines would be d squared equals r1 squared plus r2 squared minus 2 r1 r2 cosine of theta 1 minus theta 2. And I know it's still not exactly the same because you guys, again, I know you're used to your ABCs instead of using the R values, but this is a variation of law of cosines. And if you look in the book, that's how they're going to show you that they came up with it, is using law of cosines. Good news, it's easy to use. So I'm ready to try example 5 when you are. Compute the distance between the points 2, 5 pi over 6, 4, pi over 6. So what are we given here? Two polar coordinates, which means we're given, okay, R1 theta 1, R2 theta 2. And officially it doesn't matter which you make your 1 or 2. Okay, it's going to work out pretty much this. It's going to work out the same in the end. Okay, D equals the square root. Okay, R1 squared, so I'm going to say 2 squared plus R2 squared, 4 squared, minus 2 times R1, which is 2, times R2, which is 4, times cosine of 5 pi over 6 minus pi over 6. Okay. Do some cleanup is my recommendation. What do you know about 2 squared plus 4 squared? 20. 4 plus 16, so it's going to be 20. Minus, what about 2 times 2 times 4? 16 cosine of, what about 5 pi over 6 minus pi over 6? 4 pi over 6. But 4 pi over 6 reduces to be 2 pi over 3. Okay, I'm going to keep working this by hand because 2 pi over 3 is on my unit circle. That's one of those values I can figure out. So square root of 20 minus 16 times, okay, cosine of 2 pi over 3. Well, cosine of 2 pi over 3 is going to be in relation to what? If we know 2 pi, if we need 2 pi over 3, we need to look at pi over 3, right? We need 2 pi over 3. Officially on our chart, we look at pi over 3. What do we know about the cosine of pi over 3 according to our chart? It's 1/2. What do we know about cosine in quadrant 2? It's negative. So the cosine of 2 pi over 3 is negative 1/2. Well, that works out nicely, doesn't it? Because half of 16 is 8. Officially, it's a minus 16 times a negative 1/2, which really means it's going to be plus 8. So the square root of 20 plus 8 is going to be the square root of 28. In terms of doing this by hand, the farthest I can do is to go and rationalize it or simplify it and say 2 square root of 7. Now, let's talk calculator for a moment. This one I had the option of being able to do by hand because 2 pi over 3 I know. I can figure out. You won't always be an angle you can know. So could we have plugged this into the calculator right here? Or technically, I guess, even the step up above. Now, what mode do I need to be in here? Radians. 2 pi over 3 is radians. So you need to be in radians, which I am. I can see it up there. So I'm just going to do square root 20 minus 16 cosine of 2 pi divided by 3. I got an answer up there. Do you have an answer up there? Now, coincidence? Not really. Guess what the square root of 28 is? Same thing, isn't it? Okay, so we worked it up here by hand. You know, we could have put in the calculator 5.29. We worked it by hand, got square root of 28, which is 5.29. So in terms of decimals, either way, the answer works out to be approximately 5.29 or 5.3. Again, there's different places that you could stop and put that into the calculator if you're going for a calculator answer. If directions say they want an exact answer, exact is square root of 28 or 2 square root of 27. An approximate answer is 5.29. Okay? Now, excuse me, if you haven't copied it down, you want to do that. The homework is page 492, 1 through 4, 7, 8, 11 through 14, 27, 31 through 34, 51, 52, and 58 through 60. Now, 2 things. You guys all got a polar coordinate graph yesterday, yes? Okay, on that one, I think I said 1 through 4 yesterday. It's not 1 through 4. It's 7, 8, and 11 through 14. My recommendation when you put those on here is that, you know, you're going to have 6 different dots on there, right? Problem number 7, I would label as dot 7. Problem number 8, I would label the dot as 8. Same thing with 11 through 14. Okay? One other thing I need to talk about. 31 through 34. Have you looked at them? 31 through 34 says use your graphing calculator, and it gives you an equation, right? For instance, 34 is what I looked at this morning. What was 34? 34 is r equals 4 sine 3 theta. And it says to use your grapher to match the equation to the graph. Well, okay, let's graph this. If I go and graph on my calculator, I hit y equals, yes? And notice, what do all those begin? With y equals. What does this equation have? It's a polar coordinate equation, so it has r and theta. Notice this has y, and when I type it's going to have x, isn't it? Okay, go check out your mode button. So if I go to mode, the line below radian and degree says function, parametric, polar, and sequence. So arrow over to polar and hit enter and change your mode to polar. And then, now, note, you're going to have to change it back to function when you want to graph anything else, right? Look what happens when I type y equals, or I hit the y equals button now. They no longer say y equals, do they? They say R1 through R6. Now, I still have my equation typed in from this morning. So go ahead and type in 4 sine 3 theta. Now, how do you get the theta? The same way you normally get an x. Hit your x button, that's your variable button. Now that we're in polar form, it's going to type a theta instead of an x. Okay? You do need to be in radian mode for this to work. In this case, because I have a trig function in here. Anytime you use sine, cosine, tangent, and a variable, you have to be in radian mode. Okay? If you're not radian mode, it looks totally different, doesn't it, Abby? I'm guessing, yeah, that was just a guess there. So now if I graph this, I'm going to do a zoom 6 to just standard it. There's my graph. I don't know. It did. Okay, so I kind of like the polar graphs. They're fun shapes sometimes, you know. This one's a cool looking, I think of it as a flower in my brain, but whatever you see. Okay. So that's how you're going to do 34, because now I can grab my book and look at 31 through 34. The question was, which one does this match up with? Well, which one does this match up with? That's A. So 34 is A. Now you just have to practice graphing 31, 32, and 33. Okay? So that's a fun thing. I find those as fun. Maybe they're not fun to you, but it's not horrible. It's not a difficult task to use the calculator there. Okay?